Now that we know how to find values and work with them a little bit, now we're going to start translating graphs. Okay, so when we work with translating graphs, if we look at the sine curve, it's going to be a sine of b times x minus c plus d, where a, b, c, and d all do different things to the graph. Now, if you've taken Algebra 2, you know how to translate graphs a little bit, okay? Because you were translating left and right and up and down and shrink and widen and all that stuff, okay? So, what do these letters stand for? Well, A deals with the amplitude, which is a stretch up or down. So that's going to be the stretch there. B deals with a period, which is a stretch left or right or left. Because I should say right first. So you're going to stretch it down or you're going to shrink it down, basically. C is the phase shift, right or left. So you're going to slide it right or left. And D is the shift up or down. So we're going to work with A, C, and D today. We're going to work with A, C, and D. We're going to leave B for later. Next week, actually. So let's look at y equals 2 sine of x. Well, what I'm going to graph, first of all, is I'm going to graph in a different color. That's why we brought our colored pencils. Y equals sine of x. So, on graph paper or in your notebook, but sometimes it's easier on graph paper, you draw the coordinate system. And I used to go 4, but now I go 6 to get to pi over 2. Because then it tends to work better. So if you go every 6 spots is a pi over 2. Then it tends to work the best. And then I go 2 spots up and down to get to 1. Okay, so your normal sine curve. We found out from our last lesson that the sine of 0 is 0, the sine of pi over 2 is 1, the sine of pi is 0, the sine of 3 pi over 2 is negative 1, and the sine of 2 pi is 0. Okay, I'm not going to graph pi over 4 or those. But don't make a straight line here and like that and that. They're not straight lines. They're curves. So please, when you graph them, make them look like curves. Okay, so that's the sine curve. Okay, now we want the y equals the 2 sine of x. So I'm going to change my color. 2 deals with the amplitude. It's going to be 2 times whatever the y value is. 2 times whatever the y value is. What's 2 times 0? 0. So if it's y value of 0, it doesn't change. What's 2 times 1? 2. So at pi over 2, we're going to be up at 2. At pi, we're at 0. So what's 2 times 0? 0. 3 pi over 2, 2 times negative 1 is negative 2. And at 2 pi, we're at 0. So it's going to be twice as high. Ooh, a little bit off there. It's going to be twice as high and twice as low. How's that look? Easy peasy lemon squeezy, right? Okay. Let's throw a negative in here and let's throw a cosine in here. So let's go y equals negative 1/2 cosine of x. Y equals negative 1/2 cosine of x. All right. Now, if I'm going to graph y equals 1/2 cosine of x, I'm going to first graph y equals cosine of x. What's the cosine of 0? 1. What's cosine of pi over 2? 0. So then it's negative 1, 0, 1 again. And again, don't make it a straight V. Make it a curve. Like that. Now, when you have amplitude, when it's out in front, you're going to take negative 1/2 of the y value. So what's negative 1/2 of 1? What's negative 1/2 times 1? Negative 1/2. What's negative 1/2 times 0? Very good. It's 0. What's negative 1/2 times negative 1? Positive 1/2. Negative 1/2 times 0 is 0. Negative 1/2 times 1 is negative 1/2. So then the resulting graph looks like that. All right. Y equals sine of x minus pi over 6. Y equals sine of x minus pi over 6. All right. So, what do you think we're going to graph first? Y equals sine of x. What's the sine of 0? 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, 2 pi, 1, or 0. Now, what position is that minus pi over 6 in? Is that A, B, C, or D? C. So that's going to be a left-right phase shift. So it's going to just slide the graph left or right. So it's minus C on the original formula. Okay? So it's minus a positive number. So we're actually going to go a positive number, so we're actually going to go to the right, pi over 6. Okay? So basically, inside the parentheses, you would do the opposite of what you think, because it says minus pi over 6, so you think left pi over 6, but you're actually going right pi over 6. Okay, so on my graph, I have 12 squares to get to pi, right? 12 squares to get to pi. What is 1/6 of 12 squares, or 1/6 of 12? 2. So how far to the right am I going to shift my graph? 2 squares to the right. So this goes 2 squares to the right. This goes 2 squares to the right. 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 If you don't have squares, you just guesstimate. Okay? If you don't have squares, because you're doing it on your notebook, you just guesstimate about pi over 6. Now, pi over 4 is halfway in between pi over 2 and 0, so pi over 6 is just to the left of pi over 4. When it comes to the test, you'll be taking the test on graph paper, so you will have to know, how many squares you go over. But the graph is really light, so if you're a little bit off on the test, that's fine. Okay? But that's a phase shift left. Or a phase shift right, I mean. Okay? Now we'll do one that's a shift down. So let's say we have y equals cosine of x minus 2. Y equals cosine of x minus 2. So again, we're going to first graph y equals cosine of x. Now, when I make my graph, I'm going to think ahead a little bit. I see it's minus 2 for my d term, right? So I know it's going to shift down a couple. So when I make my graph, I make my y-axis just a little bit longer below the origin. So this is 1, this is negative 1, this is negative 2, this is negative 3. So 1, 2, 3, 4, 5, 6 to get to pi over 2. 1, 2, 3, 4, 5, 6 to get to pi. 1, 2, 3, 4, 5, 6 to get to 3 pi over 2. 1, 2, 3, 4, 5, 6 to get to 2 pi. So if I graph normal cosine of x, where does normal cosine of x start? 0, 0, or 0, 1? 0, 1. At pi over 2, it's 0. At pi, we're at negative 1. At 2 pi, or 3 pi over 2, we're at 0. At 2 pi, we're at positive 1. Now, since it affects the d, where are we going with the graph? Well, it says minus 2, so we're going to go down 2. It's happening on the outside of the parentheses, so it's, the sign tells us where we're going. So we're going down 2. So all our y values are going down 2. So instead of at 1, I'm at negative 1. Instead of being at 0, I'm at negative 2. Instead of being at negative 1, I'm at negative 3. Instead of being at 0, I'm at negative 2. Instead of being at 1, I'm at negative 1. So it's just the graph shifted down. And there we are. Okay. So that's the basics of graphing with phase shifts, amplitude shifts, and shifts up or down. Okay. So, you do not have to determine amplitude, phase shift, and range for these. I just want you to graph them. But we're working on page number 117. We're doing 63 through 71, the odds. That gives you 5 problems to graph out for Friday. And then on Friday, what we'll be doing is putting multiple things together in one graph. So we'll be having an A and a C and a D all in the same graph. So you'll be shifting things around. So that's why we want at least 4 colored pencils or 3 colored pencils come Friday. That would be nice. Okay, there you go.